Your phone recognizes your face in the dark. A security camera flags a suspicious bag left unattended. An app looks at a photo of a mushroom and tells you whether it's safe to eat. All of that is AI, looking at the world and making sense of it. But how? You and I learned to see as babies. Months of staring at faces, objects, light, shadow, until our brains just figured it out. We can't even explain how we do it. We just do. So how do you teach a machine to do the same thing? That's what we're unpacking today. Here's the problem. When you look at a photo of a cat, you see a cat instantly, effortlessly. When a computer looks at the same photo, it sees nothing but numbers, millions of them. Each pixel in an image is just 3 numbers representing how much red, green, and blue light it contains. That's it. No shapes, no edges, no concept of fluffy or 4 legs or whiskers. Just a giant spreadsheet of color values. The early approach to fixing this was to write rules. Programmers tried to manually describe what a cat looks like, define edges, fur textures, ear shapes. It failed spectacularly. There are too many variations. Cats come in every size, color, position, and lighting condition imaginable. You simply can't write enough rules to cover all of reality. So researchers had to think differently. Instead of writing rules, researchers tried something radical. Show the computer millions of examples and let it figure out the rules itself. Imagine you've never seen a dog in your life. Someone shows you 10,000 photos of dogs. Big ones, small ones, fluffy ones, short-haired ones, sitting, running, sleeping. And every single photo is labeled dog. Eventually, your brain would start noticing patterns. 4 legs, a snout, ears, tail, eyes facing forward. You'd build an internal model of what dog means, not from a rule someone gave you, but from experience. That's exactly what modern AI vision does. It's called supervised learning, and it starts with a massive labeled data set. Now, how does the computer actually learn from those examples? Through something called a convolutional neural network, or CNN. Don't let the name intimidate you. The idea is elegant. Think of it as a series of filters stacked on top of each other. The first filter is very simple. It just looks for basic edges and lines in the image. Horizontal lines, vertical lines, diagonal lines. That's all. The second layer takes those edges and combines them, finding corners, curves, simple shapes. The third layer combines those shapes into something more meaningful. A circular shape here, a pointed shape there. Things that start to look like eye, ear, nose. By the time you're at the final layer, the network has assembled all of those simple building blocks into a full picture, and it makes a call. Cat, dog, car, mushroom, face. The deeper the network, the more layers it has, the more complex the patterns it can recognize. But how does the network learn which filters to use? This is where it gets clever. At the start of training, all the filters are essentially random. The network is just guessing. It looks at a photo of a cat and says, bicycle. Obviously wrong. The system measures how wrong it was. This is called the loss, and then works backwards through the network, making tiny adjustments to every filter to make it slightly less wrong next time. This process is called backpropagation. Do this millions of times across millions of photos, and those tiny adjustments compound. The filters get better. The predictions get more accurate. The network gradually learns what a cat actually looks like, not because anyone told it, but because it practiced until it stopped being wrong. The results of this approach have been genuinely staggering. In 2012, a moment researchers now call the ImageNet moment. A deep neural network beat every previous record at recognizing objects in photos by a margin so large it shocked the entire field. Within a few years, AI vision had surpassed human accuracy on certain benchmark tests. Today, the same underlying technology powers face unlock on your phone, self-driving car cameras, medical imaging that can spot tumors radiologists miss, and the content moderation systems that scan billions of images every day. All of it tracing back to the same simple idea. Show it enough examples, let it practice, and it figures out the rest. And yet, it has a very particular kind of stupidity. AI vision systems can be fooled by things that would never confuse a human. A small sticker placed on a stop sign can cause an AI to identify it as a speed limit sign. A single pixel changed in exactly the right way, invisible to your eyes, can cause a network to completely misclassify an image with total confidence. These are called adversarial attacks, and they reveal something important. The AI isn't truly seeing the way you and I see. It has learned to recognize statistical patterns in pixel data. It doesn't understand what it's looking at. It just knows what patterns tend to correspond to which labels. That distinction matters a lot, especially when AI vision is making decisions in the real world. So what does this mean for you right now? It means you already use AI vision dozens of times a day without noticing. Every time your phone unlocks with your face. Every time you search Google with an image instead of words. Every time an app tags your photos automatically, or a filter tracks your face in real time. And the tools are becoming genuinely powerful for everyday problems. Google Lens can identify plants, translate signs, find products online, and solve handwritten maths problems just by pointing your camera. That's computer vision in your pocket for free. But knowing how it works means knowing where to trust it and where to be cautious. It's extraordinary at recognizing patterns it's seen before. It's fragile in situations it hasn't trained for. Unusual lighting, unusual angles, anything that falls outside its experience. Just like a very well-read person who has never left the library. Millions of labeled examples. Layers of filters building from edges to features to objects. Millions of tiny adjustments until the guessing stops. That's how AI sees. Not with eyes, with math, practiced until it looks like intuition. Next time, we're going from vision to voice. How does AI understand what you're saying? Not just the words, but the meaning, the sarcasm, the context. That one's going to make you think differently about every voice assistant you've ever spoken to. Subscribe so you don't miss it, and we'll see you in the next one.